All right. Good morning, ladies and gentlemen. Welcome to the 2018 Calculus BC FRQ Part B. We're going to be going over 4 questions. Our time limit is 1 hour, but we may take longer. We may take less time depending on the problem. My goal is not just to solve it, but also to try to explain the concept behind it. So, I guess for this purpose, right, the time limit is not my focus. Okay, but let's get started. Question number 3. We have the graph of G, and it's defined from -4 to 8. And we see that the graph consists of 2 linear pieces and a semicircle. Then we're given a function for f of x, which is composed of 3x plus an integral. Find f of 7 and f prime of 7. Okay. Let's start with f of 7. All I got to do is plug in 7 into the x, which means we're going to have 3 times 7 plus the integral from 0 to 7 of g of t dt. F of 7 equals 21 plus, now the value of the integral is going to come from the function. And because we have shapes, we're going to be using triangles, circles, and all that stuff. But we're doing the integral from 0 to 7. So looking at the shape right here, we need to calculate the area of the semicircle. And then the next part, hopefully you don't miss it, there's actually a small rectangle. Even though there's a discontinuity, you can still draw the rectangle, right? Because we're finding the area under the curve. Okay, so a semicircle and a rectangle plus 1/2 pi r squared plus base times height. F of 7 equals 21 plus, now the radius of the semicircle is 3, but because it is below the x-axis, I'm going to go ahead and make it negative from this moment on. The base of my rectangle is 1, the height is 3. And now we just go and simplify. 21 minus 9 over 2 pi plus 3, and that equals 24 minus 9 over 2 pi. One of the biggest mistakes that I saw in this part of the question was that we forgot to make the semicircle negative. It's below the x-axis. You got to put a negative. Okay. Now the other one, f prime of 7. Well, before I find f prime of 7, we first have to find f prime of x. And that means we're going to take the derivative of 3x, and we're going to take the derivative of the integral. Now the integral cancels, and the limit of integration gets plugged into the function. That's my f prime of x equation. Next, we plug in the 7. And g of 7, that's just the point, right? That's 3. Oh, whoa. Look at this mistake right here. What am I doing? Those are 3's. F prime of 7 equals 6. The mistake that I saw in this question was that when we took the derivative, we forgot to derive the 3x. I still saw some of you leave it as 3x. And then you plug in the 7, giving you 21. That's crazy. This question, I believe, was worth 2 points. I don't have, let's not look through the answers. Find the x value at which f attains a maximum. Okay, general steps. If you want to find a maximum, you need to find your derivative. You need to set it equal to 0 to find your critical points, and then do the number line. That's the general steps. At which f attains a maximum. Well, we already established that f prime of x equals 3 plus g of x. Then you set it equal to 0. Then you solve for x. And then you ask yourself, where does the function of g attain the value -3? And that's at the bottom of the circle. Let me show you real quick. That's right here. Where does it attain it? At x equals 3. So at x equals 3, that is my critical point. Now, normally, actually, yeah, the number line. We just want to know where it attains the maximum. So I think the number line will be very, very helpful here. So we're going to take our derivative, f prime of x. And we're supposed to plug in numbers, but take a look at your interval, right? We're only going to 3, and 3 is the critical point. So technically, 3 is going to be the last value, nothing after that. And we're going to go from -4 to 3. So I'm only really choosing one value to plug in, and I can choose whatever I want. So let's go ahead and plug in 0. F prime of 0 equals 3 plus g of 0. F prime of 0 is 3. G of 0, according to the graph, is 0. So that means that derivative is positive. Now, what this means is that from -4 to +3, the function is continuously increasing. And if a function is continuously increasing, doesn't that mean the maximum is going to be at 3? Right? Doesn't matter where you start. We know we start at -4, but we don't know where on the y values. We just have an increasing function until you get to x equals 3. So since f of x is increasing on the interval from -4 to 3, it attains its maximum value at x equals 3. That was the only critical point, and it also happens to be the end point. Okay. C. Find the two limits. Okay. The limit as x approaches 0 from the left of the derivative of g. This means that we're supposed to be looking at the slope of g from the left. So if I look at the graph, as I approach 0 from the left, I see that we have a linear function, and the slope is going to be the same. We don't actually have to get to the point 0, but we're just looking at the slope as we approach 0. And because it's a linear function, we can just do rise over run. The rise is -1, and the run is +2, which means the slope is -1/2. So -1/2. The limit as x approaches 0 from the right of the derivative is undefined because there's a vertical tangent. I'm just giving you guys the justification, but in the rubric, it doesn't give you the point for that. You just have to state that it's undefined. Now, let me show you why. As you approach 0 from the right side, we're traveling along the semicircle, right? So once you get closer and closer and closer and closer to 0, you're basically dealing with the side of a circle, right? And when you're dealing with the side of a circle, at that point, we have a vertical tangent. And a vertical tangent has an undefined slope. So you just have to say undefined, and you get the point. And I don't know if you have to get both of them correct, or if it was 1 point per question, but there was really no justification needed. It was just -1/2, undefined. D, find the limit as x approaches -2. First, you need to try to check the limit straight up. Some of you just went straight to L'Hopital's, but you don't always have to use L'Hopital's. So first, just plug it in. And don't forget the notation, because if you look at the rubric, you're only going to get 1 point maximum, even if everything is right, but you miss the notation. So there we go. Here it is. So don't forget the notation. The limit as x approaches -2 as x approaches -2. Now f of -2. I got to do that on the side. F of -2, it's 3 times -2 plus the integral from 0 to -2. That's -6 minus the integral from -2 to 0. -6 minus. From -2 to 0, we have a triangle. So we're going to use 1/2 base times height. The base is 2. The height is 1. -7. So f of -2 is -7. Which is 0 over 0. Now you can use L'Hopital's. The first point is for showing that you get 0 over 0. So, L'Hopital's. The limit as x approaches -2 of f prime of x divided by e to the 3x plus 6, and then you multiply times the derivative, times 3. Then you go ahead and plug in the -2. F prime of -2 e to the -6 plus 6 times 3. The slope at -2, oh, we already calculated that. That's -1/2. No, that's not it. F prime of x is 3 plus g of x. So f prime of -2 is 3 plus g of -2. And g of -2 is 1. So that's 4. E to the power of 0 is 1. 1 times 3 is 3. So we get 4/3. That's a lot of work. But hopefully nothing too crazy. Nothing too difficult. And remember, the goal is not to be perfect. The goal is just to get as many points as possible. Hopefully 4 per question. That should be our minimum goal. Okay. Oh, number 4. This is the one that I thought was very tricky when I was doing it myself. Let g be the function that satisfies g of 0 is equal to 0 and whose derivative is 2 times the absolute value of x. Find the expressions for g of x and g double prime of x. At first glance, I guess I was a little, nervous, because I was like, what's the derivative of an absolute value? What's the antiderivative of an absolute value? But then when you start thinking and processing, remember, the graph of an absolute value is a V-shaped graph. So technically, then an absolute value function, you can break it apart into a piecewise function. So you can say g prime of x equals the first part is a negative linear function. So -2x for x is less than 0. That piece defines the first line segment. The second segment is a positive linear function for x is greater than 0. Now, since the function is technically defined, one of those has to have an equal sign. And it doesn't really matter which one. But when you're the one making it, we usually give it to the first one. But again, it's not wrong if you do it to the other one. So that's our derivative. Now, if I want to find my antiderivative, g of x, then we're gonna find the antiderivative of -2x, which is negative. Here, I'll do it on the side. G prime of x equals -2x My antiderivative is negative x squared plus c. Then I can use my initial condition to solve for c. So that means my derivative is just negative x squared for x is less than 0. Let me make this bigger. So at the same time, we're also going to get x squared for x is greater than 0. Now, I saw that in the rubric, they created a second point for 0. They did this. And the first time that I did the problem, I didn't do that. I just put an or equal sign. I'm pretty confident both are going to be correct. All right, but I'm just going to leave it the way the rubric has it. A point at 0. So that's your g of x function. Now, your second derivative, well, we're going to go back to g prime, and we're just going to go ahead and derive it. So that's going to be negative 2 for x is less than 0, and positive 2 for x is greater than 0. None of them are going to have the little equal sign at the bottom, because g prime is a corner. You can't derive corners. The derivative doesn't exist. So there it is. There's your g of x, and there's your g double prime of x. Find the x coordinate of the point of inflection for g. If I want to find a point of inflection, we need our second derivative. We need to set it equal to 0 to find our critical points. And then we got to do a number line to check if it switches signs. Those are the general steps. So g double prime of x is equal to 0. But technically, it also counts if the derivative is undefined. That would also qualify as a critical point. And even if you didn't do part A, as long as you know the graph of g prime, you can answer this question. The graph of g prime of x, which is an absolute value graph, is a V-shaped graph that's a little bit steeper because it has a slope of 2. Just look at this whole graph. When does the derivative equal 0, or when does it not exist? At the corner. You can't derive corners. So the derivative is equal to 0 at x is equal to 0 because g double prime is undefined. You don't have to state that. I'm just telling you for your own learning. Now, is it actually a point of inflection? Well, technically, you don't even have to do the number line because the graph is a better number line. A number line just gives you signs. An actual graph tells you what's happening. On the left-hand side, the slope of g prime is negative. On the right side of 0, it's positive. So yeah, it's a point of inflection. We have a point of inflection at x is equal to 0 because the slope of g prime, which is g double prime, changes from negative to positive. So technically, you didn't even have to do part A to do this part. I just reason through it. Know your basics. C. Use Euler's method with 2 steps to approximate H of 4. Once again, we don't need part A for this one. So that's why it's important when you're taking the actual test to not get yourself psyched out by a question you don't know. Just move on. Move on and keep calm. So Euler's method is using a bunch of tangent lines. And what do we need for tangent lines? We need a point. And we need a slope. Because with that, we're going to be able to make tangent lines. Now, we're starting at x equals 0. Let h of x, for x is greater than or equal to 0, h of x is the length of the graph of g from t is equal to 0 to t is equal to x. Use Euler methods to approximate it. Okay, so after reading the problem again, I realized I don't have a y value. So we're going to have to go get the y value. H of 0 equals the integral from 0 to 0. That's just 0. So there's my y value. I'm also going to have to find the slope. How do you find slopes? By taking derivatives. H prime of x equals, you got to know your fundamental theorem of calculus here. If I take a derivative, the integral cancels and the x gets plugged in. So the square root of 1 plus 4x squared. You also have to multiply times the derivative of the limit of integration. But the derivative of x is just 1, so it doesn't matter. Now the slope at x equals 0 is 1. There's my slope. So what's my tangent line? My tangent line is y equals 1 times x minus 0 plus 0, which is basically just x. Now, we want to take 2 steps to get to 4. So my next step would have to be 2. That's my next x value, 2. Do I know my y value? No, I don't. But that's what the tangent line is for, right? To get the new y value. So you plug in the 2. Here, let me do this. You plug in the 2 and you get your new y value. You also have to go get the new slope. H prime of 2 equals the square root of 1 plus 4 times 2 to the power of 2. And that equals the square root of 17. So your new tangent line is going to be the square root of 17 x minus 2 plus 2. My next step is going to be 4. I need the y value, and that's what the tangent line is for. So you can get the new y value, right? So y equals the square root of 17, 4 minus 2 plus 2. The new y value is going to be 2 radical 17 plus 2. That's it. So h of 4 equals 2 radical 17 plus 2. If you don't know the table, that's okay. It's just know the concept, right? It's about making a tangent line. You get the tangent line to get the new y value. Then you build another tangent line, and you use that tangent line to get the next y value. You're just taking little steps. Okay. D. Find the integral of this. Or another question where we don't need part A to be able to start it. I think we're going to need it to finish it, but just to start it. Whenever you see a product of 2 very different functions, that's an indication you're going to have to do integration by parts. Because U substitution is not going to help you here, right? So you need to pick a U that gets simpler as you derive it, and you got to pick a dv that you can easily integrate. And if you pick the wrong thing, it's okay. Just go ahead and erase it and start again. But my u is going to be g prime of x, and my dv is going to be cosine of x. I guess maybe I was a little bit wrong. Maybe you do need part A to be able to do this, because g prime of x is 2. And, well, I haven't really done anything with my dv. So now, if I derive this, oh no, it's not 2, it's 2x. If I derive it, I get 2 dx. And if I integrate this, I get sine of x. You don't got to put a plus c. That's going to come later. So here's your u and your du, your v and your dv. So ultraviolet vu ru. It's u v minus the integral of v du. That looks very similar, so let me fix that. V du. So u v. Now, even though you're doing uv, really careful here, because we're actually supposed to find the value. We have limits of integration. They apply to these guys, from pi over 2 to pi, minus the integral of v du. So I'm just going to go ahead and put the 2 in the front. Okay. Now, really careful here, because it's going to get long. We have to evaluate this part of our problem by doing our f of a minus f of b minus f of a. So 2 pi times sine of pi minus 2 times pi over 2 times sine of pi over 2 minus the antiderivative of 2 sine of x is negative 2 cosine of x, evaluated from pi over 2 to pi. Okay. Well, this part right here is 0. This part, the 2 cancels with the 1/2, so that leaves us with pi, and sine of pi over 2 is 1. Minus. You know what? Let's say plus, because we have a double negative right here. So now we have 2 cosine of pi minus 2 cosine of pi over 2. There we go. So this gives us negative pi plus 2 times negative 1 minus, this part is 0. This gives us negative pi minus 2. That's the answer. My other recommendation is that if you get something wrong because of a concept of a formula, to not move forward until you know the concept. Okay. Now, if it's something that's really, really hard and you just have no idea, then move on. Because we're also going to focus on the easy ones and the medium ones. But if it's something that you're like, oh shit, this is not too bad, like, focus it, memorize it, and don't move on till you got it. Part 5, question 5. Okay, we have a differentiable function. At the start of the reaction, t is equal to 0, there's 10 grams. That sounds like an initial condition to me. Use the line tangent to the graph of f at t is equal to 0 to approximate the amount of substance remaining at 2 seconds. Without even reading much of the question, I see tangent line. I know how to do tangent lines. I need the slope, dy dt, which is negative 0.02y squared. And we're supposed to do it at t is equal to 0. But my slope equation doesn't have a t, it only has a y. Well, y represents the amount of substance. And at t is equal to 0, there's 10 grams present. That means y is 10. So dy dt equals negative 0.0210 squared, which is negative 0.02 times 100. And because I'm multiplying by 100, all I got to do is move the decimal point twice. So that's negative 2. That's my slope. My point at t is equal to 0 is 0, 10. The problem says there's 10 grams present of the substance. So my tangent line is y equals mx minus x1 plus y1. Negative 2x plus 10. And I'm supposed to use this to approximate how much substance there's going to be at t is equal to 2. So that's going to be negative 4 plus 10, which is 6. 6 grams of the substance is present at, oh man, at t is equal to 0. No, not 0. 2. At 2 seconds. Okay. B. Using the given differential equation, determine if the graph of f could resemble the following graph. Well, the graph, we don't know what the graph of f is, but we know that dy dt is equal to negative 0.02 t squared. Y squared, not t. Y squared. Now, my slope is only dependent on the y value, right? Not the seconds, just the y value. And it doesn't matter what we plug in into y. This part is always positive. But we're going to take that and we're going to multiply it by a negative. So, no. This graph cannot resemble using the differential equation, determine whether the graph can resemble the following graph. Cannot resemble f since dy dt. Oh man, I don't know what I do that makes it do that. Well, how far did it push me? Well, it took me like all the way to the beginning. This graph cannot resemble f since dy dt is always negative. And this graph has a positive slope. For part of its domain. That's this part right here. Phrase it however you want. You look at the rubric, it'll say something slightly different, but it's basically communicating the same idea. And I'll put over here, always negative. So negative times a positive is a negative. Okay. Find an expression for y by solving the differential equation. Oh man, last year I told you guys that this is the question that I would love for you to have on the real AP test because there's a lot of points on this, especially in an AB class. And there's a little bit less points on the BC class because you're just supposed to know it. But it's still a part where we can get a lot of points. So dy dt equals negative 0.02 y squared. You can't take the antiderivative straight up. We're taking it. This is a differentiable function with respect to t, and there's no t's. So you have to use separation of variables. So I'm going to go ahead and divide by y squared, and I'm going to multiply by dt. That should get you a point by separating the variables. Before I find my antiderivative, I'm going to go ahead and change that up. Then we're going to add 1 to the exponent, and we're going to divide by the new exponent. The antiderivative of negative 0.02 dt, we'll just add a t plus c. And if you simplify this, we're going to get negative 1 over y equals negative 0.2t plus c. This is where we use the initial condition, which is 0, 10. So if I plug in my 10 and I plug in my 0, I get my value of c. Then we're going to take that new c value and then find the equation for y. So I'm going to start from here. So negative 1 over y equals negative 0.02 t minus 1 over 10. I can multiply by a negative. This is where it gets tricky because I think I saw some students trying to flip it. But you got to be really careful with that. So I'm going to do this before I flip it. That's going to be 2 over 100 because it's in the hundredths place, right? Then I'm going to get a common denominator. Oh, let's simplify this. 5 over 50. Okay, this is going to be t plus 5 over 50. And then you can flip it. Because if you try flipping the other line, it's going to get a little tricky. And I don't know if you'll do it correctly. Trying to flip this one, you should have gotten something like this. It would have been y equals 1 over 0.02 t plus 1 over 10. That's what it should have been. And I don't know if you guys are going to flip that part correctly. Okay. Part D. Determine whether the amount of substance is changing at an increasing or decreasing rate. Is the amount of substance changing? That's talking about the derivative. Is the derivative increasing or decreasing? So we have to derive the derivative. No, it's not t. It's y squared. So my second derivative with respect to t is going to be negative 0.04 y times dy dt. And what do we know about dy dt? Well, we know that dy dt is negative 0.02 y squared. So if you simplify this, you're going to get positive 0.0008 y cubed. And that's always positive. The amount of substance is changing at an increasing rate since your second derivative is always positive because there's always going to be substance, right? Y is the substance, and there's always substance. So it should be positive. I'll finish the last one later. Thank you very much.